7.1 continued. This video is going to be going over examples 4 and 5. I promise it won't be as long as the last one. These examples do go faster. They're more algebraic than anything, though we will have to keep referencing our values for the domain since we are being asked to find the domain for f and f inverse. So two domains we're going to have to find. So find the inverse and then state the domain. So let's state the domain of the original. Please look back at your notes from chapter 6 if you need to, but I did go over this in the video for the first part of 7.1. Sine. The domain for sine. So the domain for f of x is negative infinity to infinity. Your sine graph goes on forever. Negative infinity to infinity. So that part's done. Now we need to find the inverse, so then we can find the domain of the inverse function. So inverse. To find the inverse, we switch x and y. So x equals 2 sine of y minus 1. Now we want to solve for y. So my first step is going to be to add 1. So it cancels here. I can move the 1 because it is not in parentheses. It is being subtracted from the sine of x, not x. So now I have x plus 1 equals 2 times the sine of y. And then I can divide by 2 because 2 is being multiplied to the sine of y. So I now have x plus 1 over 2 equals the sine of y. Now I still need to solve for y. I need to get y by itself, so I need to undo sine. And to undo sine, I need to take the inverse of both sides. So sine inverse, sine inverse. Those cancel. Y is by itself, and it equals the sine inverse of x plus 1 over 2. This is your inverse function. So f inverse of x, sine x plus 1 over 2. So I found the inverse. Now I need to find the domain of the inverse function. The domain of the inverse function, remember the graph goes this way, and it's going from negative 1 to 1. It is set up so it is the domain x has to be in between negative 1 and 1. Well, normally it's sine of x. X is by itself. But here x is not by itself. It's with an x plus 1 over 2. So that piece, this, needs to be put in for x. So I'm going to have negative 1 is less than or equal to x plus 1 over 2 is less than or equal to 1. So now we have to get x by itself. So I'm going to multiply both sides by 2. So I get negative 2 is less than x plus 1 is less than or equal to 1. Just kidding, 2. Then I'm going to subtract 1. So negative 3 is less than or equal to x is less than or equal to 1. This is the domain of f inverse of x. So we found the domain of the original function, negative infinity to infinity. We found the inverse, and we found the domain of the inverse. All right, let's do the next one. So moving on to b, we're going to find the inverse of the tangent function. So I'm going to start by finding the domain. Domain of tangent. We need to remember that tangent has asymptotes, and they're asymptotes every multiple integer of pi, odd multiple integer of pi over 2. We're not going to repeat them all. We need to remember that tangent has an asymptote at negative pi over 2 and pi over 2. There's our asymptote. There's our tangent graph. And we're only going to identify this as just one cycle, one period of tangent. So we're going to say that x has to be between negative pi over 2 and pi over 2. However, just like in the last one, it's usually just tangent of x. But here it's an x plus 1, so that must go in the middle. So negative pi over 2 is less than x plus 1 is less than pi over 2. Not equal to, because these are asymptotes. Then I subtract 1. You don't need to worry about getting a common denominator, you guys. You can just say negative pi over 2 minus 1 is less than x is less than pi over 2 minus 1. So that's the domain of the original function. That's f of x. Now we need to find the inverse. Find the inverse, we're going to switch x and y. X equals negative tangent y plus 1 minus 3. So I'm going to start by adding 3. I don't know why I wrote a 1. X plus 3 equals negative tangent of y plus 1. Now this negative here, I'm actually going to leave it. I know in the last one I divided by 2, and I did that because it was a number other than 1. If it was 1, we would have left it. If it was negative, I would have left it. And the reason I leave it is because tangent is an odd function. And if I divide by a negative, eventually I'm going to have to pull that negative out to the front. And then it's just going to put it back. So I'm going to leave the negative. I cannot move the 1. The 1 is actually being added to the y. Where back here, this 1 was being subtracted to the 2 sign of y. So it wasn't being subtracted to y by itself. Here, this 1 is actually being added to just the y. So I can actually take the inverse of this function now. So I can take the inverse, tangent inverse, tangent inverse. So now my tangent is going to cancel, and I am going to be left with tangent inverse of x plus 3. Then I'm going to move my negative. So here, this cancels. Let me change my color back. Tangent inverse of x plus 3 equals negative y plus 1. Now I'm going to divide by negative 1, and that negative is going to end up out front regardless. So let me switch this around because I prefer to see the y on the left side. So y plus 1 is going to equal negative tangent inverse of x plus 3. Now I'm going to move the 1. So now I'm going to subtract 1. So y, or f inverse of x, equals negative tangent inverse of x plus 3 minus 1. There's your inverse. And then the domain of tangent inverse, because the graph of tangent inverse looks like this. It goes this way. Negative infinity to infinity. So domain here. Negative infinity to infinity. All right, let's get this last example done. There are 3 of these, I think. Yes. Finding the exact solution. So get that unit circle out or that trig chart, whatever it is that you use. So I want to find x. Before I can find x, I need to get the sine inverse of x by itself. So then I can undo the inverse. So I'm going to start by dividing by 3. So sine inverse of x equals pi over 3. Now I can switch these. So now I no longer have the inverse. So this is going to be the sine of pi over 3 will equal x. Just don't forget, because it's inverse, we're looking in quadrants 1 and 4. So I want to find the sign at pi over 3. Well, that's nice. That's automatically in quadrants 1 and 4. So let's see, I go to pi over 3. The sign is root 3 over 2. That's my x value. Now let's move on to b. In b, we're going to divide by 3 first. So I have cosine inverse of 2x equals 2 pi over 3. Can't move the 2 because it's protected with that x inside the parentheses. So now I'm going to switch. So this is going to be the cosine of 2 pi over 3. I'm undoing the inverse, equals 2x. Now use your unit circle here. The cosine at 2 pi over 3 is negative 1/2. And it equals 2x. So I'm going to divide by 2. I'm taking a fraction and I'm dividing it. So it's going to end up giving me a smaller number because I'm dividing it by 2. So I'm going to take the reciprocal, so it's going to be times 1/2. 1/2 times negative 1/2 is 1/4. So I have negative 1/4 equals x. And the last one. Here looks tricky, but it's actually not. I just need to combine like terms. So I have a sine inverse x and a sine inverse x. I'm going to subtract the smallest one. So I'm going to subtract 2 sine inverse of x. So it cancels here. And I am left with 3 sine inverse of x minus 2 pi equals negative 3 pi. Now I'm going to put the pi's together. So I'm going to add 2 pi. Cancels. 3 sine inverse of x equals negative 3 plus 2 is negative pi. I can divide by the 3 because it's being multiplied to sine. Sine inverse of x equals negative pi over 3. Now I'm going to undo the inverse. So sine of negative pi over 3 equals x. You should know where negative pi over 3 is. Negative pi over 3 is the same as 5 pi over 3, not 5. 5 pi over 3. Or you can use the fact that sine is odd and move the negative to the front. So this is negative sine of pi over 3. So the sine at pi over 3 is root 3 over 2. So negative root 3 over 2. All right. Hope this makes sense. If you need to rewatch it, rewatch it. If you need help with anything, please make sure that you do come in and ask for help. I will be happy to help you do your practice problems, and I will see you tomorrow.